Alright, so in this problem, I have x to the power of 3 plus x is equal to 10. So to solve this, I'm going to first start by subtracting 10 on both sides. So now I have x to the power of 3 plus x minus 10 is equal to 0. Now negative 10, that's the same thing as negative 8 minus 2. So now I'm going to switch the order of these and rewrite this as x to the power of 3 minus 8 plus x minus 2 is equal to 0. So now 8 is the same thing as 2 to the power of 3. So now I have x to the power of 3 minus 2 to the power of 3 plus x minus 2 is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, x to the power of 3 minus, x to the power of 3 minus 2 to the power of 3, I can rewrite as x minus 2 times x squared plus 2x plus 2 squared, which is 4, plus x minus 2 is equal to 0. So now if I factor out x minus 2, I get x minus 2 times x squared plus 2x plus 4 plus 1 is equal to 0, which is the same thing as x minus 2 times x squared plus 2x plus 5 is equal to 0. So now to solve this, I have two equations. I get x minus 2 is equal to 0 and x squared plus 2x plus 5 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2, so this is one solution. And for x squared plus 2x plus 5 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, b is equal to 2, so I have negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 5, all over 2a, so 2. Now this is the same thing as negative 2 plus or minus the square root of 4 minus 20 over 2, which is equal to negative 2 plus or minus the square root of negative 16 over 2. Now the square root of negative 16 is the same thing as the square root of 16 times the square root of negative 1, and the square root of negative 1 is equal to an imaginary number I. So negative 2 plus or minus the square root of, square root of 16, which is 4, times I is the square root of negative 1 over 2, which is equal to negative 1 plus or minus the square root of 2i. So two more solutions. Alright, so in this problem, I have x squared minus y squared is equal to x minus y squared. So to start, I'm going to first start by expanding x minus y squared. So now I have x squared minus y squared is equal to x squared minus 2xy plus y squared. So now these two x squared cancel out if I subtract x squared on both sides. So now I have negative y squared is equal to negative 2xy plus y squared. And now I'm going to add y squared on both sides and add 2xy on both sides. These two cancel out, these two cancel out, and I have 2xy is equal to 2y squared. Now I'm going to subtract 2y squared on both sides. These two cancel out, and I get 2xy minus 2y squared is equal to 0. Now I can factor out 2y. So now I have 2y times x minus y is equal to 0. So now this gives me two equations. I have 2y is equal to 0, and I also have x minus y is equal to 0. So for 2y equals 0, this means that y is equal to 0. And if x minus y equals 0, this means that x is equal to y, and remember y equals 0, so x is also equal to 0. So both of these variables are equal to 0. Now, I have another method of solving this. I have x squared minus y squared is equal to x minus y squared. So now I'm going to rewrite x squared minus y squared as x plus y times x minus y. And now I'm going to divide both sides by x minus y. So then these two cancel out, and I'm left with x plus y is equal to x minus y. Now, I have x plus y equals x minus y, and I can cancel these two x's out. So now I have y is equal to negative y, meaning 2y is equal to 0, and y is equal to 0. So again, I get y equals 0. So now to check, I had x squared minus y squared is equal to x minus y squared. If both of these are equal to 0, then I have 0 minus 0 is equal to 0 minus 0 squared, meaning 0 equals 0. Alright, so in this problem, I have 4 to the power of x is equal to 40. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 4 to the power of x is equal to log 40. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this can equal b times log a. So in this case, I have log 4 to the power of x, so I can move x to the front. So now I have x times log 4 is equal to log 40. Now, I'm going to go ahead and divide both sides by log 4. So then these two cancel out, and now I have x is equal to log of 40 over log 4. Now, log 40, this is the same thing as log of 4 times 10. Because log 40 is equal to 4 times 10. So I have this over log 4. And now if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 4 times 10. So this is equal to log 4 plus log 10. And now I have this over log 4. Now log 4 plus log 10 over log 4, this is the same thing as log 4 over log 4 plus log 10 over log 4. And log 4 and log 4, these two cancel out. So now I have x is equal to 1 plus log 10 over log 4. So now log 10, this is the same thing as 1. Log 10 is equal to 1. So now I have x is equal to 1 plus 1 over log 4. And log 4 is equal to 0.602. So now I have x is equal to 1 plus 1 over 0.602, which is equal to 1 plus 1.66, meaning x is equal to 2.66. Alright, so in this video, I'm going to be solving the problem 7 to the power of 100 minus 7 to the power of 97. So, for my solution, I'm going to rewrite my problem right here. And the first thing I'm going to do is I'm going to rewrite 100 as 97 plus 3. So I get 7 to the power of 97 plus 3 minus 7 to the power of 97. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of 97 plus 3 is going to equal 7 to the power of 97 times 7 to the power of 3. And I have this minus 7 to the power of 97. Now from here, notice how both of my terms have 7 to the power of 97 in them. So I can simply factor out 7 to the power of 97, and I get 7 to the power of 97 times 7 to the power of 3 minus 1. And 7 to the power of 3 minus 1 is, well, 7 to the power of 3 is 343. So I get 343 minus 1, which is equal to 342. So I get 7 to the power of 97 times 342. So this is my answer in simplest form.